Hi, Foundations 10. This is the first that you're going to see one of these little videos in the course. I'm going to hopefully have them tied in here and there all the way through, where instead of reading notes, you can go actually watch a bit of a video to help you see what's going on. They are entirely optional. They're there if you need more than the notes give you, or for that matter, if you'd rather watch those instead of the notes. This lesson is on something called a greatest common factor, which you'll hear called a GCF. You've worked with a GCF before. What's the G stand for? Greatest. What does greatest mean in math? In math, it simply means the biggest. So if we're going to find a greatest common factor, we're looking for the biggest. Common. What in the world does common mean? If I ask you and your best friend, what do you have in common? You may tell me we both like a certain kind of music, you both love cars, you both hate math for that matter. Common is something that both things have. So in this case, we're going to say both things. In math, of course, these are going to be numbers. How about? And F is factor. Greatest common factor. What in the world is a factor? If I asked you to name a factor of 12, for instance, most of you would immediately say 2. What makes 2 a factor of 12? You would tell me, well, it goes into it evenly. Those are not good math words. What does goes into mean? It divides into it evenly. So what are factors of 12? What goes into there? 1 does, 2 does, 3, 4, 6, 12. Those are factors of 12. Factors of a number are always smaller than the number itself. Always, always, always. Okay, whoop-de-doo. Now we know what GCF stands for. How do we work with it? Let's say I asked you to find the greatest common factor of, let's go, 18 and 42. There are two good numbers. We could go this way. What are the factors of 18? Well, we know 1 goes into 18, and 2, and 3, 6, 9, and 18. What are the factors of 42? 1 goes into it, 2 goes into it, 3. Does 4? Nope. 5? Nope. 6 does. How many times? 7. And now you can see I'm working backwards. If you've never realized this, there's 42. How many 3s are in 42? 14 of them. How many 2s are in 42? 21. And how many 1s? 42. There are the factors of 42. Now to find the greatest common factor, meaning the biggest that's in both lists of factors. Is 1 the biggest common? No. But it is common. This one is a common factor. This is a common factor. This is a common factor. Are they the greatest? No. If you look down the list, the greatest common factor, the biggest number in both lists is 6. 6 is, how about is the greatest common factor of 18 and 42. Is this the most efficient way? I don't think so, but if it works for you, it is an accepted method. Let's do this again a different way. We're going to find the GCF of, let's go with 68 and 144. Now if I asked you to list out the factors of these, the lists are going to start getting pretty long. There's got to be a better way. Somewhere along the way you've learned how to do either a factor tree, which looks like this, or, and I don't have a name for it, same idea though, and you set it up this way. Either way works to find what I'm going to call a prime factorization of each number. What's prime mean? It doesn't factor. It doesn't break down. You know what prime numbers are, right? Let's go with a smaller pen here. So if I want to break down 68, I'm going to say, hey, well, you know what? It's 2 times 34. I can see that easy enough. Keep the 2. What goes into 34? 2. Whoops, I did it again. How many times does 2 go into 34? 17 times. So 68 is really 2 times 2 times 17. If you do it this way, all it looks like is 2 comes out of 68, leaves 34. Another 2 comes out, leaves 17. There's your prime factorization. Same process either way. Okay, so let me start with a clean page here for a second. We know that 68 is 2 times 2 times 17. We need to do the same process with 144. 144, 2 goes into there 72 times. 2 goes into there 36 times. And 2, and 18, and 2, and 9, and 3, and 3. 144 is the same as 2 times 2 times 2 times 2 times 3 times 3. Realize those are just the numbers that are here. Now, because we're working with a greatest common factor, here's our factor list for each of these. Let's go in and actually pick out what's common. They have a common 2. Oops. They have another common 2. This one has a 17. Is there a 17 down here? No. This has a 2 and a 2 and a 3 and a 3. None of those are up here. These ones aren't common. They aren't shared. What do I know now? For 68 and 144, the GCF is whatever 2 times 2 is. 4 is the greatest common factor of 68 and 144. That's all there is to finding a GCF. Now what if I ask you, what's the GCF of 12, 18, and 42? Does anything change? Not really. If you write out 12, it's 2 times 2 times 3. Notice I put my numbers from smallest to biggest. For me, that's the easiest way to organize and then find the things that match later. 18 is 2 times 3 times 3. 42 is 2 times 3 times 7. Now what's common? There's that 2. What, is there anything else in common? Is there this 2 shared? No. However, there's a 3 common to all 3 lists. Now we look, is there anything else? And it has to be in all 3. If these were both 2's, it's not enough unless there's a 2 down here as well. This is it for the greatest common factor. We know that 6 is the greatest common factor of 12, 18, and 42. Now, where in the world is this used in math? You've probably been introduced to the GCF repeatedly in the past. Think about this one. What if I ask you to add 15 over 42 and 3 over 18? If you're going to reduce a fraction, you know you divide by the biggest thing that goes into both of them. In other words, you divide by the GCF. If you're going to add 2 fractions, you need to get this to be the same. How do you get it to be the same? That's the next lesson. To get those to be the same, we actually do something called a least common multiple. Okay, back to your notes. There are some questions, some more examples to do in the paper, and then there's some least common multiple stuff.